Thank you for joining us today. Before we start our today's session, let me quickly brief you about the VOLANSYS. Moving on to the next. So before we start the webinar, let me quickly go through the webinar schedule for today. We'll cover presentation in first 45 minutes and then we'll follow up with the Q&A session. You can raise your questions in the comment box and then we'll address all the questions at the end of the webinar. Those questions which are left out, we'll address them later through email communications. Thank you for joining us today. So before we start the webinar, let me quickly talk about what VOLANSYS does. So we are one-stop solution enabler having expertise in building end-to-end product, starting from the component selection, hardware component selection, board design, firmware development, device driver development, quality testing, and many more. So we are end-to-end product engineering and ODM service provider. We also connect our products with the cloud environments and offers various cloud computing services. And then we develop connected applications and mobile applications. We have global presence, Silicon Valley based company with the design centers in USA and India. Moving on to the next slide. So as I just said, we offer product engineering, software engineering, mobility services, quality engineering, cloud and big data related, and business analytics, which covers the entire IoT spectrum. So we are end-to-end IoT system provider. Moving on to the next slide. Yeah, so I am handing over to our today's speaker for the webinar. Neet, if you can introduce yourself.
Yeah, sure. Thanks, Nupur, for the opening. Hi, I'm Neet. I have more than 6 years of experience in design and development of cloud applications. I'm also been involved in architecting few solutions lately. I have worked in multiple domains like IoT, semiconductor, and industrial automation as well. So today's agenda is we are initially we are going for the standard clouds skeleton like a platform as a service, software as a service, and infrastructure as a service. Then we are going to talk about a few key challenges while building any cloud solution. Then afterwards, we are going to talk about few ready-made or the outbox services that is available in the market, which can help us to create any cloud solution very faster, which can also help us to reduce our time to market. And then after on the main portion, we are going to talk about cloud orchestration in what, why, and how part. Following with the VOLANSYS real world case study that how VOLANSYS has done cloud orchestration for one of the client. So I'm sure many of you are familiar with these terms, IaaS, PaaS, and SaaS. So let me quickly go through each component. Uh, IaaS is infrastructure as a service, means providing resources like computing, storage, networking, etc. as a service. So the famous examples are like Amazon's AWS, Microsoft's Azure, and Google Cloud Platform. IBM Bluemix is also one of them. Then platform as a service, also known as PaaS, means providing a platform like operating systems, SDKs, or app engines like services. So which can covers middleware, APIs, and runtime environments as well. And followed by the famous SaaS, which means software as a service, means providing a software application on top of certain infrastructure and platform as a service. This is the highest usage of any cloud platform. So these all are known as a public cloud, means your data and code does not lies within your premises. We are talking about Amazon, Google, IBM. In a certain situation or for a certain segment, people do not want to go with the public clouds. If you don't want to have your data on a public cloud, then you can still go for the hybrid cloud or a private cloud, where you can store entirely within the premises, or you can have few data on the premises and few data on the cloud. So that is the traditional on premises cloud, which has been shown in the diagram at the left corner. So let's now talk about a few challenges which are most of the people have been faced while implementing any cloud solution. So it divides in a certain parts, starting with the interoperability and portability. So the integrations with the existing infrastructure is one of the standard challenge. So most of the time we have to integrate cloud with some existing application or the existing infrastructure. So depending upon the third party application, we may face issues with our workflow implementation. We may have to change our workflow as well. And cloud to cloud connector is one of the most common thing to have in this challenge. Again, up in the porting a cloud in a preset or a pre-configured environment is also a biggest challenge. The second challenge is compliance, security, and privacy. So many healthcare related cloud solutions faces the challenge with the compliance, privacy, and the security of the data where they don't want to keep on the cloud. So maintaining the privacy in a multi-tenant system is also very challenging, where the same database contains all the information of the various clients. The third one is very popular one is managing cost. So this is one of the most common challenge with the growing customer base. Bills of the resources are also growing exponentially. Thus, selecting the right subscription model is a key thing to stop converting our profits into the deadwood. Fourth one is performance optimization. So nothing is perfect, thus everything has a room of improvement. So does the cloud systems. So giving a seamless experience to the end user is a key thing. And optimizing resources, optimizing the application is always been there. The next is continuous integration and developments, also known as CI/CD. So, in the era of globalization, having multiple teams in various countries, it's quite unique or a common thing that so many teams are working on the same projects. So, in such case, continuous integration becomes a necessity. In order to provide a smooth upgrades to the users, continuous deployment on a pre-production and the production server is also key thing. The last one is the lack of resource or expertise. So once your solution is been ready up and running on the production, it becomes more critical to have a ready team which can maintain or be ready for the any error or troubleshooting. So in a world of fast moving technologies, maintaining such solution requires a team of expert people, which also a challenge. So these are the few common challenges for cloud solutions. So let's talk about infrastructures. So as I mentioned earlier, a typical cloud has the skeleton of three parts: infrastructure, platform, and a software. So within the infrastructure, there are three subcategories. One is computing, the second one is networking, and the third one is storage. Uh, Within the computing, what we typically use are the servers, which means high performance cloud servers or a virtual server, based on hourly or monthly pricing. Then containers, again the very famous concept nowadays, which has AWS Fabric or AWS Elastic Container Registry and Services, which can help us to self-healing and horizontal scaling. The third one is scaling, where we allow our instances or we allow our containers to be scaled automatically, or we also configure our environment to string so we can optimize our profits or we can optimize our resource utilization. The third one is functions and executors. Sorry, the last one is, so these containers or these services allows us to run our code headlessly, which means you don't need to have a entire instance for your code. AWS Lambda, AWS Elastic Beanstalk, IBM's Code Functions or IBM's WebSphere, Azure's Cloud Service, and Google's Cloud Functions are typical example of this. On a networking side, network appliances where you need to configure firewalls and VPNs. Load balancer is also one of the key portion where you need to configure and manage the incoming load within within the application. Domain name services, uh, helpful for multi-tenancy. Content delivery network, again very helpful, where your application end users have been divided in various geographical. In the storage section, there are particularly many databases or many containers are available. Each and every famous cloud platform providers or cloud service providers have their own proprietary solutions, like Amazon's DynamoDB. They also provide a ready-made container of the famous databases like MongoDB or Cassandra. It also comes with the various types and size bifurcation. Means if you want to manage zettabyte data or petabyte data, then also AWS has their own products for certain solutions. The next is a platform as a service, which means we are talking about middleware, security, and DevOps things. In the middleware, operating systems, data management, business rules, and APIs are there. For the security part, identity and access management, SSL certification, hardware security modules are there. In the DevOps, log analysis, workload scheduler, continuous integration and continuous delivery, and cost management. These are the famous components which are available. So all of these components have ready-made services from a very famous service provider like AWS and IBM. The last one is software as a services, where we mostly focus on productivity. So the search, IoT platform, rule engine, artificial intelligence, or mobile services like push notification and analytics. All those containers are being divided in software as a service. So we just touch upon all the skeleton or all the components of a typical cloud. So now we are going to talk about how these components needs to be orchestrated. So the typical cloud journey starts from the standardization, where once your entire cloud has been up and running, the first step is to standardize the components, standardize the modules that That's where we are going to reduce our cost, we are going to increase our performance, and we most important thing is we are going to reduce our complexity. So using standardized components is the key thing and the very first thing. The second step is consolidating entire system, which means improve efficiency and improve management and control. The third one is the virtualization. So most probably the newer cloud or newer instances are running on a single instance or a bare metal server. Once your system is stable, the virtualization step needs to be applied, which means we are again going to reduce the cost and increase the utilization. It also provides a higher flexibility to entire infrastructure. Once utilization has been virtualization has been implemented, the next thing is automation, which means automating our deployment, automating a few tasks or a few maintenance activities, which will obviously give improved user experience, and which will also help us for the time to market speed. And the last step is orchestrate. So many times people do confuse between automation and orchestrate. So the automation is a technical task and the orchestration is the IT workflow composed of the task. So automation, we can say, is a subset of orchestration, which means that orchestration provides coordination among the many automated activities, and on the other hand automation focuses on the making one task repeatably with minimal operator intervention. Cloud automation codifies the task. On the other hand, cloud orchestration codifies the processes. So these are the very basic differences between cloud automation and cloud orchestration. For the cloud orchestration, there are famous tools available nowadays. Amazon's Cloud Formations, OpenStack's Heat, and Microsoft Azure's Resource Manager are the popular tool which can help us to orchestrate cloud using their services. We can also orchestrate a cloud using our own services, which means DevOps guy can help us here. So, what is the cloud orchestration? In a one liner, it's a cloud inspired IT service model for the arrangement and the coordination of multiple automated tasks in the cloud solution for optimum process and workflows, which means we are optimizing or we are collaborating cloud operations, DevOps operations, and IT operations. So cloud orchestration does not contains any of the software, or it does not contains only any of the infrastructure part. It contains all the things like configuration, automation, scaling, flexibility, predictive analysis, and speed up the things. To achieve this, there are certain tools available like a Docker, Puppet, and Chef, which can help us to integrate cloud operations with the DevOps operations. So, why cloud orchestration needed? It will help us to increase speed and agility. It will help us for the faster infrastructure deployment and provisioning across the disaggregated platforms. So if you guys are doing some cloud deployments, then you may also know that a typical deployment takes 2 to 3 days. Cloud orchestration can certainly help at that particular area. The second benefit will be efficient cost management. Since we are doing container based services, we are opting into the model of pay as you go. The third one is compliance, security, and privacy. Continuous integration and deployment help us to have this compliance and security. Improved visibility and control, since backups, migration, and deployment are automated. So we are also having the zero downtime and auto recovery here. Improves staff productivity, which means staff is going to work on a more productive things. They can design more strategic initiatives and improve customer experience, means self-service capability with error-free delivery can help here. So for I would like to highlight few reports here. So the 81% of organization recognize that optimizing cloud application or workload is a critical thing or a highest priority. Intel's report suggested that cloud orchestration market is expected to reach at 14 billion US dollars by 2020, and owning a growing demand among this business will certainly helpful. So how VOLANSYS has done a cloud orchestration for one of the client, or how VOLANSYS helped one of the client building entire orchestration from scratch as a customized service. So this client has remote digital signage and POS device management, through which they want to do content delivery using cloud, and they are selling this cloud as a platform as a service or a PaaS. So the business challenges were remote device management and content deployment should happen via cloud. That means reduce the extensive time involved in loading dynamic content on each device, uh, providing a powerful and engaging set of business tools to device owners for remote device configurations and content display management, location based advertisements and promotional offers, cross sell and upsell promotional activities. Client also wants to support a remote OTA for the devices, and it has analytics part as well for the device and user, which means gather device data to enhance customer experience, and health data for predictive maintenance. So as a solution, Volansys has provided various modules like device health monitoring, where temperature, CPU, and RAM utilization has been analyzed. For the user analytics, time spent on a particular device or demographic like gender and age, these data have been collected. For the content management, different type of content library or different type of content can be uploaded on the cloud, like apk, url, or offline website. There are smart contents which can have a combination of these two. Drag and drop for the selected content in terms of download, install, and launch. And device status information for device notification, and monitor the current content display. So the solution architecture, what Volansys has proposed and what Volansys has implemented is on the Android application side, it has SDK development, then Android BSP layer development as well. Then we have a load balancer. So all the requests to the cloud are being routed via this load balancer. On the cloud part, we have Cloudflare's content delivery network implemented, then SSL security for the increased security. TLS 1.2 and TLS 1.3 protocols are enabled. Backup and recovery servers are there. For the application server or for the web server, we have used Nginx. For the application user interface or for the UI, we have used AngularJS. AngularJS has connected with the WebSockets to the Node.js backend code. And on the database side, there are hybrid database structure. Elasticsearch has been used for the logger analysis. Redis has been used for the real-time communication. CouchDB has been used for storing user and device data. And Microsoft Azure's large storage has been used to store large contents which user has uploaded. For the analytics part, entire Elk stack has been implemented with the Elasticsearch, Logstash, and Kibana. It also contains a logger analysis and monitoring system with the tools like New Relic. For the deployment, it contains Jenkins with AWS integration, where we can do auto deployment. For continuous integration and continuous delivery, it also automates test cases on the Bitbucket and Jira. For the DevOps orchestration, the ideal flow was commit and starting from the commit and build application, then put a version control on top of that. So the build repo could be Bitbucket or Git or Artifactory or something else. Then version control system, and on top of that, commit and build infrastructure means once your build has been ready, uh, the infrastructure also needs to be spawned via command. Once build is being generated, we are going to validate and test out that particular build using tools like Jenkins or Bamboo. At the same time, validation of automation packages can be done via Chef, VMware, and Puppet. Once validation is been done, deployment of the infrastructure and deployment of the application needs to be done. So the infrastructure can be deployed via Docker Swarm or Chef or Puppet scripts or Kubernetes as well. And deployment of the application can be done via Jenkins. Once application and infrastructures are there, we need to test that entire infrastructure. So the acceptance test needs to be executed first with the help of Splunk and EMC. Once acceptance tests are done, the capacity test needs to be executed with the help of Hudson or Travis or cruise control. And capacity test has been done, then production deployment needs to be done with the help of Cucumber or Metasploit or the Artifactory. So these deployments can happen with various tools, but all the deployments needs to be followed by a particular set of processes where DevOps orchestration takes place. So what benefits delivered to the client once we delivered this entire solution? So their solution or their platform became a self-service cloud platform, reduced customer acquisition time since they have a customized subscription model. They have converted their entire platform in a container services, so they can spawn a new infrastructure with the new environment very easily. The scalability means rapid allocation and deallocation of resources with the pay as you use model. Faster deployments are there since container services with the Docker implementation, and the reduced cost means operational cost and administrator costs are reduced. So this was what Volansys have delivered to the end customer in terms of cloud orchestration. The similar orchestration can be achieved with the AWS CloudFront or Microsoft's Azure Resource Manager, uh, or we can also customize the orchestration with the help of DevOps processes. So, thank you guys for the presentation and for the attendance. You can share your questions in the question window. So, well, we have the first question from the one of the attendee. What do you see as the most important elements of orchestrating and deploying containers? So, typically, orchestrator offers three core capabilities: provisioning, scheduling, and discovery. Provisioning means scaling containers up and down dynamically. Scheduling means matching containers to available resources, and discovery means ensuring microservices are able to communicate with each other to operate as a single application. This enables three major benefits like scalability, application can quickly and easily scale; reliability and availability, which means orchestrator employ automation to deploy and run application, reducing the likelihood of operational issues. And third one is flexibility, which means software development and operations become easier to manage. How has the orchestration and deployment of containers changed application development? So the first part is it saves time. Containers provide a standardized modular unit for packaging applications, which can deploy and run easily and consistently in different environments. This reduces the time required for developers to build application as well, and it allows developers to focus on building smaller application components rather than having to integrate the components within the large application. The second part is it automates development workflow. It actually enforces automation of the development workflows. Containers can enable development processes to benefit from increased automation that reduce complexity. What's the future of containers? Uh, Containers are going to drive significant innovation, I would say. Containers are the building blocks that will form the basic of hyperscale computing and Internet of Things. And large solutions are still early in the adoption of containers and microservices, but as they're part of strategic transition, they all are eventually end up with the microservices based container based architecture to take maximum advantage of their solution and the investment that they do in the infrastructure. So another question is, what do developers needs to keep in mind when working on a orchestrating? So developers needs to think about how orchestration platforms fit in with the existing developer tooling. That means CI/CD tools or the pipeline and the build management system needs to be thought through while development. Successfully leveraging orchestration platforms require ensuring that they are interoperable with the tools and workflows. That means they are flexible enough, they are modular enough to have the orchestration and container based services. So this seems to be end of our discussion. So thank you for your presence. Bye. Having a nice day.